All right, so in this video we're going to talk about solving logarithmic equations. Especially we are going to talk about how to use the definition of a logarithm in order to solve a logarithmic equation. And if you are able to do that, it just makes the process really, really easy if you remember how to change things from logarithmic to exponential and vice versa. Okay. So, this is especially helpful to use when you have a logarithm on one side of the equation, and I'm talking one logarithm on one side of the equation, and a constant on the other. So I've got a logarithm is equal to a constant. This is the technique you want to utilize then. Okay, so come back to this idea. Log base 5.1 of x is equal to 3.2. How do I write that as an exponential equation? Start with that base, 5.1. Raise it to the power on the other side. 3.2 is equal to x. Oh, well, I've got my answer then, right? Because I've just rewritten it in a form that is more pleasing to me. 5.1 raised to the 3.2. Oh, I don't know that off the top of my head, do you? So let's go ahead and calculate that. 5.1, raise that to the 3.2. Looks like 183.75 or 183, let's use 3 decimal places, 0.749, okay? So the only real trick or thing to be aware of using this kind of technique is if there's more than one logarithm on one side of the equation and a constant on the other, then you want to condense those two logarithms into a single log. So if there's more than one logarithmic expression on a side, condense to a single log. Remember, check your answer in the original equation, and this is something kind of important. You want to reject any value that generates a negative argument. Remember that we cannot take a logarithm of something that's not positive. So if I get an answer, I don't know, let's see, what if I got an answer here of 0, and I plug in a 0, and I've got 2 times 0 minus 1, and I'm trying to take a log of a negative 1, can't do it. So you always want to go back to your original equation, sub it in, and make sure that your argument doesn't end up being negative. That doesn't mean that we can't get negative answers for our variables. It just means when I sub it in to the logarithm that my argument is not negative. Okay, so now we've got a few examples that we're going to look at. And we're going to see if our logarithmic equations fit this profile of a single log equals a constant. And if they do, we're going to rewrite them as an exponential equation instead. If they don't, we're going to see if we can make them look that way and then write them as an exponential equation. So let's look here. We have a logarithm equals a constant. Ding, 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 yay. We can go ahead and rewrite this as an exponential equation. Start with the base, come over here, equals the argument. Base to the power equals argument. 3 to the 4th power is equal to x minus 5. Oh, well, that looks easy, right? Because I know 3 to the 4th power is 81 is equal to x minus 5. And then bringing that 5 over, we end up with x is equal to 81 plus 5, or 86. Now, I always want to go back and check. Take that 86 up here. 86 minus 5, 81. Oh, positive argument, good. Is log base 3 of 81 indeed equal to 4? We know it is. We are good to go. Okay. Here's example 2. Oh, log and constant on one side, 0 on the other. This is not exactly what we want. Okay, let's make it into what we want. We want a log on one side, a constant on the other. Let's move this constant over. Log of x is equal to 2. All right, so now let's rewrite this in exponential form. What is the base? I don't see a base. Remember, if the base is missing and it says log, base is So this is really 10 squared is equal to x. Oh, x is 100. Huh, okay, let's double check this. Log of 100, I think that's 2, isn't it? Oh yeah, it is 2. 2 minus 2 is equal to 0. We are good to go. All right, coming over here. Logarithm equals a constant. The constant can be 0. That's okay. Okay, so now let's rewrite it. What's the base here? That's that other special logarithm that we see that doesn't have a base explicitly written. Okay, so the base, when you see ln, is e. So this is e to the 0 power. Base to the power is equal to the argument. E to the 0 equals 2x minus 1. What is anything to the 0 power? Last time I checked, that was 1. 1 is equal to 2x minus 1. Add the 1. 2 is equal to 2x. Now, let's divide both sides by 2. X is equal to 1. Let's go ahead and check. Come up here, plug in the 1. 2 times 1, that's 2. Minus 1, that's 1. So ln of 1 is equal to 0. Is that right? That's right. Anytime you take ln of 1, you get the 0 out. Or a log of anything. Log of 1 with any base is 0. Okay, coming back over here. Oh, let's box this so we know what we're doing. Come back over here to this example. All right. Log. Oh, I've got a 2 in front of that. Okay. Got a 2 in front of the log equals 4. I don't want this. I want just a log is equal to a constant. Well, there's a couple different ways that you can do this. You can either use the power rule and bring this here, or you can divide out this 2, which is what I would probably do. I would probably just divide out this 2 here and say, well, now I have log base 5 of 3x is equal to 2. Okay, looks good to me. Now I've got a log is equal to a constant, so I can rewrite it. Base to the power equals argument. Okay, so 5 squared is equal to 3x. 25 is equal to 3x, so x is equal to 25 over 3. Okay, let's double check. 25 over 3, bring it here. 3 times 25 over 3, that's 25. Okay. Okay, so we know it's not negative. Log base 5 of 25, isn't that 2? Times 2 is equal to 4? Fantastic. Okay, how about this one? I want a log is equal to a constant. It's not what I got. So let's make it what we got. Let's move the 5 to the other side. Subtract the 5 from both sides, and I would have 2 ln of x is equal to negative 1. Okay, we're getting closer. Now I have 2 times the log is equal to a constant, so let's get rid of the 2. Let's divide that by 2. Okay, so ln of x is equal to negative 1/2. Okay, we're getting there, okay. So now I've got a log is equal to a constant. Okay, so I want to rewrite it in exponential form. I think that would be e to the negative 1/2 is equal to x. Oh, I've got x. Okay, so this is good. Let's even bring it to something that's even better by getting rid of the negative exponent, which is, kind of a no-no, right? So x would equal 1 over e to the 1/2 power, right? Because that negative exponent flips it to the bottom. Or you could even write it as a radical, 1 over the square root of e. Okay, let's double check. Let's take this right up here. All right, and this is not any negative argument, so we are good to go. All right, so last one of these examples, and we'll call this one good. Okay. Logarithms, but more than one. Okay, so what happens when there's more than one? We want to condense them into a single logarithm, okay? So we want to go and put this into one logarithm. Remember when we've got a subtraction thing going on, we can write it as 1 log with a quotient. So the positive part goes on the top, the negative part goes on the bottom, negative meaning this, right? Is equal to 1/2. Okay, now I have a log is equal to a constant. So now I can rewrite it in exponential form. Base to the power is equal to the argument. Okay, so this kind of looks ugly, but it's not so bad if I get rid of this fractional exponent. Isn't like the half power, isn't that the same as the square root? Well, we know the square root of 4. We know that to be 2. So we're going to call this 2. And we're going to get rid of our denominator. Remember that if you've got something in the denominator down here, we're going to go ahead and multiply both sides by it. X minus 1 here, x minus 1 there. And these would cancel, right? And now I've got 2x minus 2 is equal to x. So we're so close to being done. Let's subtract this x, add this 2, and I think we get x is equal to 2. Right? Let's see. Subtract that x, add the 2, x is equal to 2. Okay, so when I substitute this in, it does not yield anything negative. I'm good to go. All right, so the next step in solving logarithmic equations will be solving using that one-to-one property. We'll cover that next time.